Okay, number 9. Well, the thing to do right here would be to recognize that 4 and 8 have something in common, right? First have to recognize 4 and 8 have something in common. After that, you need to think, what does solve mean? It means get x by itself on one side. So as you could see, x is up here in the exponent position, and you don't want the x up there in the exponent position. So we could apply a logarithm, but before we apply a logarithm, it would be just awesome if we could make this look exactly like this. In other words, get the same base. And like I said, the 4 and the 8 have something in common. In other words, I could rewrite the 1/4 to be 1 over 2 squared, because 2 squared is the same thing as 4. And also the 8 right there, I could rewrite 8 to be 2 to the third instead of 8 if I put the 8 in parentheses. And let's not forget about the outside 5x plus 6. Okay, so what I'm going to do now is I'm going to take this 2 squared and I'm going to move it up to the top. Now you're thinking, what, we could just do that? Actually, you could, yeah, you could just move it up. You could move anything from one side to the other as long as the exponent changes sign, right? Because if you have a negative exponent, you have to move it to the other side and it becomes positive. So if I want to take that 2 squared and move it up, that's fine, as long as when I move it up there, it becomes 2 to the negative 2, okay? So I took this and I moved it up. So it's really over 1, so you don't have to write that. But anyway, we get this new equation, 2 to the negative 2 equals 2 to the, and before I write the power, I'm going to go back up here and I'm going to distribute 3 times 5x and get 15x, and then 3 times 6 and get plus 18. So ladies and gentlemen, we have 2 to the negative 2 equals 2 to that. Now I could actually apply a log base 2 to both sides. You remember when you apply a log base 2, it'll cancel it out. You apply a log base 2, it'll cancel it out. So your new equation is now negative 2 equals 15x plus 18. And of course we go back to the original instruction here of solving. We need to get x by itself on one side. So I'm going to subtract 18, we're going to end up with negative 20 equals 15x. For my final step, I'm going to divide by 15, and of course the answer, x equals negative 20 over 15, that could be reduced by 5, because 20 is a multiple of 5, and 15 is also a multiple of 5. So if I were to divide both by 5, then I'd end up with negative 4 over 3. That's my final answer. And as you can see, that's option B. So I hope this video helps to get you to understand solving where you have to change the base to get them to be the same base. You could practice with number 10. So I'm going to skip over 10, move on to number 11. Number 11 is also dealing with logarithms, and they want us to simplify. It's not an equation. We're not trying to get x by itself. They want us to simplify. Now, I hope you guys remember the 3 different properties of logarithms. You have the power property, where your power comes out to the front. You have your quotient property, where if you have a subtraction, you could condense it and make it one single logarithm with this one over that one. So there's many things that you could do. If you're condensing, it's just a question of recognizing that this is the minus sign, so you're going to be using the quotient property. If it were a plus sign, you'd be using the product property. And we are going to be condensing, once again. So what we're going to do is take this log base 7 and that log base 7 and write them together as one single log base 7. And what do I do with the x to the 8th and the x to the 5th? Well, because it's a minus, I need to put them as a fraction. So it's going to be x to the 8th over x to the 5th. Okay, now if this would have been a plus sign, I would have actually multiplied them together, x to the 8th times x to the 5th. But since it's minus, we have the x to the 8th divided by x to the 5th. Anyhow, is there anything else that we could do to simplify? Yeah, this is a fraction. You have x's on top, you have 8 of them on top and 5 of them on the bottom. So 5 of them will cancel with 5 of them, and you're going to have 3 left up on top. So my final answer really is log base 7 x to the third power. Now, as you could see, there is no log base 7 of x to the third power. There's log base 7, 3x, 3 log base 7 of 3x, 3 log base 7 of x. So there must have been another property that's applied, and that is the power property, where you simply take the power and put it out in front of the logarithm. So your final answer is 3 log base 7 of x. 3 log base 7 of x, which is letter C. Again, practice with number 12, and we're just going to jump to number 13. I hope this helps. Let's move on to number 13. All right, number 13. What expression is equal to common log 110? Well, if you take a look at all of your multiple choice answers, they are no longer common log. They're all ln, which means that we have to really change it to become ln. So we don't want common log, we want ln. So we're going to have to use a change of base formula, okay? And I hope you guys remember the change of base formula. Let's review the change of base formula by writing log base b of c. Now, if we wanted to change that to ln, for example, then you would write ln up on top, and you'd write ln on the bottom. And what happens, the bigger number, the bigger value, goes up on top, and the base goes on the bottom as a regular number. So I will have ln of c over ln of b, right? That's the change of base formula, right? You could have anything, right? You could have a, let's go with what we actually have. Common log, which is really log base 10 of 110, okay? So you want to use a change of base formula so you could get ln's, no problem. Let's do that. You're going to have ln on top. You're going to have ln on the bottom. And the 110 goes up on top, and the 10 goes on the bottom. So there's our answer. ln of 110 divided by ln of 10. Now, you're probably thinking, well, this answer doesn't look like any of these over here. Well, yeah, because it's written out horizontally instead of vertically. In other words, ln of 110 divided by ln of 10, it's right here. ln of 110 divided by ln of 10. It's just written side to side instead of on top of each other. So that's answer B. Now, apparently, number 13 is not repeated. So we have another question, 14, that we're going to jump to. Number 14, you want to solve. Once again, you want to get x by itself. And we've already done a similar problem to this one. It would be awesome to have the same base, right? Because if this were a 2 instead of an 8, then you could just cancel out the 2's and the exponents would come down, and that would be your new equation that you could solve. So the number one thing to do right here on number 14 would be to make that 8 a 2. So let's make this 8 a 2. Bless me, right? A 2, all right. So anyways, on the left side we have 2 to the x minus 10. That's ugly, sorry. And on the right side, instead of 8, I'm going to write 2 to the third and to the x. So what do I really have? I have the base 2 on both sides, and I have a power to a power right here. So what I really have is 2 to the x minus 10 equals 2 to the 3x. Now, of course, we're going to apply a log base 2 and a log base 2. Cancels, cancels. Your new equation is x minus 10 equals 3x. And of course, you want to get x by itself on one side. So I'm going to subtract x and subtract x. And I will have 2x equals 10, which means that if you divide by 2 on both sides, x equals 5. Once again, this one is repeated, so you could practice. Try to do number 15, and you could check your answer on the post of Edmodo or from the answers in class. Let's move on to number 16, shall we? Oh, word problems. I hate word problems because I don't like reading. Okay, come on, let's get over it. Let's just read this thing. The amount of money in a bank account can be expressed by the exponential equation. Here's your equation right here. the amount is 300, which is the initial amount, times 1.005, which is the interest rate that you're earning, and then 21 times t, where t is years, the time. It says A is the amount in dollars and t is the time in years. Okay, we know that. How many years will it take for the amount in the account to be more than 1,300? So A, you want it to be more than 1,300. Okay, so you want this to be more than 1,300. Again, you want this to be more than 1,300. So let's write this out. 1,300 if we put it in the place of A, but we want this amount to be more than 1,300, so we're going to go like this. More than, should I put the or equal to? No, it doesn't say more than or equal to, it just says more than, so I'm going to erase the or equal to, it's just more than. And we need to figure this out. We have the 300, we have the parenthesis 1.005, and it's to 21 times t, okay? So let's put the power of 21 times t. So it's saying how long, right? The answer, the question is about how many years, how long will it take? So we're solving for t. Now the problem is t is up here in the exponent. We don't want it up there in the exponent. So let's do a couple of things first. Let's kind of pretend it's an equation. So I'm going to take both sides and I'm going to divide by 300. So I could get rid of that 300 and divide by 300. Okay, and the zeros cancel. So I really have 13 divided by 3. I'm going to leave it like that for now. So it's going to be 13 over 3. And it's going to be less than 1.005 21t. Okay, so we still need to bring down the exponent 21t. So at this point, I'm realizing that I'm going to have to apply log base 1.005 here and a log base 1.005 over here. So I can cancel these out and the 21 comes down. Then I'm going to have to use a change of base formula. It's sounding very complicated already. So let me give you the shortcut to this problem with this multiple choice question. It's asking how many years. They only give you 4 different options. You might as well get a calculator and type in 14 right into that t spot and see if it gives you a value more than 1,300. Type in 30 and see if it gives you a value more than 1,300, and so on and so on. So if you start by plugging in option A, just to let you know how to type it into the calculator, you're going to type in 300. So you have 300, and then you're going to hit open parenthesis. You're going to put the 1.005, and then close parenthesis, and then you're going to hit the caret button. Okay, that's a caret button on the calculator to get you to the exponent spot. And then you might as well open up a parenthesis, and you're going to type in that 21, and then times, the times button, I guess, and also the t, which since we're trying A, we're going to put 14. And if you type that into the calculator, then hit the equals button, you will get 1,300 and then 0.000176. So that's very clear that at 14 years, we get 1,300 or more. It's slightly more, so 0.00176, it's more than 1,300. So of course, 30 years, you're going to have way more than 1,300. 221, heck yeah, you're going to have way more than 1,300. But it's saying how many years will it take for the amount to grow past 1,300? That'd be option A.